Okay, welcome back. We are continuing in the process of programming up a generative art system in R, and because this is part of my robust tools class, I'm also using it as an excuse to teach a few basic programming skills in R. Our goal is to create artwork like this. At the moment, our best efforts look like, let's just have a look. Our best efforts look like this. Getting a little closer, like I feel like, this has some things in common with this, but they're clearly, falling a little short still. Um, and I want to help uh, we're going to go through a couple of steps to clean this up a little bit. So, and once we've got it cleaned up, we can create the image. Then I'm going to talk about how to save things. So, just to give a sense of where we're up to in terms of the actual programming concepts we've talked about, I've introduced lists, tibbles, and dollars. I've talked about certain random number generators. I talked about while loops and if statements. I've covered bits and pieces, mostly with ggplot, like additional ggplot content that wasn't in the original data visualization series, and some refresher things for dplyr. And I've given you a bit of a teaser of the ambient package. Hopefully we'll cover these other 2 points today in the process of finishing up our art. So let's do this. Let's stop wasting time. Okay, so there's a couple of things we're going to have to do to make this better. First things first. I really don't want that background anymore. Like, this is the default theme to ggplot. And we know how to modify themes, right? So in the data visualization series, I talked about how you can just go theme. Well, if I wanted to, I could make it theme dark, and if I did that, we would get a picture that looks like that. But instead of theme dark, I just want something that takes away the background, takes away the legend, takes away basically everything. So we'll go theme void. Theme void when we rerun that, so Control Shift S is our source thing. Okay, so that's getting a little closer now, right? So let's just tab back over here. Okay, still not quite as sort of interesting and scrawly as that one, but getting there. The first thing what I want to be able to do to kind of get this to be more like that is to be able to modify the length of our paths. Like at the moment, like the paths that we're seeing in the original are kind of long, and an individual path in this thing tends to be quite short. So it might be time to give ourselves another parameter to work with. So let me go back up to the beginning. Okay. Let's add a new parameter that I am going to call, what am I going to call it? I don't know. Okay, I'm going to call it the size of the step. That makes sense, right? So because I'm going to call it sis step. See, so they can have the same number of characters as the other ones. I know, that's pathetic of me, but now what I want to do is give it a number, like say 0.0001 or something like that, to say how far on average we should go. But I kind of like it if I can have my parameters be whole numbers as much as possible. So I'm going to do a sneaky little thing down here, right? Where over here, originally I divided it by 10,000. Sorry, by 1,000. What I'm going to do instead is say, okay, so divided it meaning the raw step. So instead what I'll do is I'm going to kind of go, I'll put things in brackets just to conceptually group things so that you can see what's going on. So we'll first divide it by 10,000, and then we're going to multiply it by, I think we're going to multiply it by the step size. I think that's the plan. Actually, let's do that. Okay, so we'll go multiply that by, okay, so it's from one of our art par, that's our parameters. Again, pull one of the parameters. We want, this time it'll be size step. It's not coming up because I haven't actually updated the Lisp. If we just go art par again, dollar step. Okay, and then we'll give this a number. Let's give it a number, shall we? So the size step, instead of 0.001, we'll say that it's 200 in relatively arbitrary units. But that at least gives us something helpful to work with. So okay, let's have a look and see what this looks like. Ooh, okay, that is cool. So this is very much part of the process of creating generative art, is kind of doing things that surprise you and going, wow, that's kind of neat. Um, that may not have been exactly what I wanted, but okay, let's go with this anyway. All right, I'm leaving it. I'm going with the flow. Okay, now one problem that you can kind of see with this as output, right, is initially um, when I when all of the art was contained within this square region. I'll just move this over so that my face isn't in your way. There we go. Initially all of our art was in this square region, but the curl steps have taken it further and further along these paths. But you can kind of see that although there were lots of points in the original square, they've ended up in this long, thin tendrils in the out in the arms. And there's a bunch of ways that we can fix this. Like, it would be nice to have a bit more puffiness to it. Don't have it collapse into single points. There's a couple of ways you can do this, but one way that I really like is to take advantage of the fact that curl noise is something that you can do in multi dimensions. In fact, you can do it in 3 dimensions. So far, everything I've done has only had an x coordinate and a y coordinate. Let's just, to be a bit clever, let's give ourselves a z coordinate as well. And we're not going to plot the z coordinate, but it is going to exist. Initially, everything can start with a z value of 0. And then we will have go down here to our little bit of our magic. So our curl noise is now going to operate on this invisible z value as well, so z. And for technical reasons, the curl noise, when we're doing this, needs 3 seed values, and I'm just going to do something that obviously you know exactly what this is. I'm just going to have 3 copies of the same number. However, if you're taking my class, you may not actually know obviously what this is. So this is a good moment for another programming lesson. Yeah, why not? Okay. C is short for concatenate, or combine, whatever you want to call it. So if I go C1, 4, 7, I get something with 3 numbers in there. It's a little bit like if I created a list. Remember at the start of this, right? I had the list. When I created the art parameters, so if I go 1, 4, 7, it gives me something that looks ghastly, but you can tell it's the same numbers, right? You've got the first thing that has a 1, the second thing that has a 4, the third thing that has a 7, and we're going to pretend that those scary double things don't exist. The point I'm trying to get at with this is that what C is doing is creating multiple things and combining them together. And lists are kind of doing the same, but just in a fancier way. So let's just clear that again. And if I go, so C equals 1, 4, cat, I get, something funny. What it's decided to do is say if, so 1 is supposed to be a number and 4 is supposed to be a number, but cat is a word and that's text. So when it's stuck those things together, it's decided to treat them all as text. Anytime you use C to combine things, they have to be of the same type. So if I just go, um, why is my cursor not coming back? Okay, are you kidding me? It does not love me. Okay, I'm just going to reload the page because obviously it's frozen on me again, and that drives me completely batty. While we just stare and look at the prettiness of this picture, and then hope that we have our project again. Please give me my project back. Thank you. Okay, so if I go X gets that, I can kind of go over here under environment, and what it'll say is X is character of length 3. So there are 3 strings or pieces of text. So if I go X 1, it says that's 1. X 2 is that. Square brackets are the tool for pulling individual elements out of things. I'm still being a bit vague about what these things are. But for the moment, let's, pretend that I'm not just talking about generic things and go over here and go list. We will go 1, 4, and instead of 7, we will say cat. When I create my list and print this out, lists can have different types of things. So I've got 1, 4, and cat. You might be wondering, if I said at the beginning, tibbles were a lot like lists. Let's see if that is true, and I'm going to do the same thing with tibbles. So go tibble, 1, 4, cat. Okay, we've done something. Let's have a look at what T is. Tibble is a 1 by 3 tibble, and it's got 3 things in it. 1, 4, cat. In each case, we have a tool for combining things together, but they have different properties and they act in different ways. For now, what I want you to get is that tibbles, which are like these rectangular data structures, is one way of combining things. Lists, which are kind of some funny mystical things that let you combine all sorts of stuff together in arbitrary ways, is another way of doing it. The thing that I've just shown you with C, or combine, is a way of creating what's called a vector. So a vector here is just a series, like I want to say a list, but I should be careful because that's a different kind of thing. It is a sequence of objects that are all kind of given the same name, and I can say grab me the first part of X, grab me the second part of X. I can even do things like this. X, give me the first and second part of X, and that will give me those sorts of things. So what I've introduced you to here is the square bracket notation, and tried to give you a bit of a hint about, a bit of an introduction to thinking about creating vectors. Okay, if we go back to our code, if you just remember what I did there, that was what I typed. Hopefully you can remember that that's what I did. So that's just 1, 1, 1, and if I just say C 1, 1, 1, and I want to type it times by 3, gives me 3, 3, 3. Okay, so it's just multiplying things element-wise. Each element in the vector gets multiplied by 3. So what I have done in this step here, where is this step? Aha! Is just basically created. So I started with a vector with 3 1s in there, and then multiplied each of them by the seed so that we've just got the same value in there. Okay, that was a boring excuse to start talking about vectors, but you actually do need to know about vectors. I promise I wasn't being a jerk for literally no reason. Okay, so vectors are handy things to know about. We've just created one. going back over here, let's go. So we're going to have this, we're moving in the z coordinate at the same time. So we're going to go z plus step z, again divided by 10,000 just for that. And because I'm picky like this, I'm going to give it, I could just say that the distance that we move in the z direction dimension is going to be the same as the other ones, but because we're going to use the z dimension to do something a little bit differently, let's give it a different name, and we'll call this, I like to think of it as slipping, because we're sort of invisibly slipping along this other hidden invisible dimension. Since we've added that as a parameter, I'd better scroll up over here and add, so the size of my slip, oh look, it's the same length again. Isn't that nice? And I'm not going to slide as far along the z dimension. Okay, what this is going to do when I run all of this is it's created an additional dimension, and it's twisting or curling the shape in that additional dimension every single time point. And what that's going to do is introduce some weird skew and distortion to what we see in these two dimensions. Anyway, to take the suspense out of this, what this has done is taken the, let's just make this bigger, object, this is what we had originally without that additional movement in the hidden third dimension. When we add that additional dimension, you can see that it sort of puffed things out a bit, and there's a little bit more variation, and it's giving it some of that wispy look. So we're a fair bit closer. We've added one new thing to our art mechanism, and we've also in the process talked a little bit more about some data structures. So this time around I talked about vectors and how to concatenate or combine multiple objects within a single vector. I talked about the relationship with lists and with tibbles, and I think I will stop this one here. I'll let you again play with the art, play around a little bit with vectors, like try using C to do things, do different things, see if you can work out how to pull out particular elements of vectors and so on. There's a great deal more to know about them than what I've just told you, but it's a start. Okay, I will be back shortly to try and hopefully the next one will finish this up. Alright, done.